Hey everybody, so in this video we're going to talk about section 6.4, which has to do with the distance and midpoint formulas, and we're also going to talk a little bit about circles in this section. Okay, so let's start with just giving the distance and midpoint formulas. Okay, so the distance formula gives the distance between 2 points. Okay, so we're calling our 2 points x1, y1, and x2, y2 just to differentiate between the two. When you have two ordered pairs, it really doesn't matter which one you label as x2 and which one you label as x1. Okay. All right, so we're taking the difference between the x coordinates and squaring it, the difference between the y coordinates and squaring it, and then we're taking the square root of the sum there. Okay, so this gives you the distance between two ordered pairs. Now let's look at the midpoint. Okay, which we use the notation x bar and y bar. Now, if you've seen this bar notation before, you know that it stands for the average. Well, the midpoint is the average, so that's why we use the same notation. Again, we're calling our two ordered pairs x1, y1, and x2, y2, just to differentiate between the two of them. Okay, so you can see that this really is the formula for the average. You add them up and divide by how many there are, so you really are finding the average of the x coordinates and the average of the y coordinates. Okay, all right. So there we have our two formulas. So let's go ahead and do a straightforward application of these two. Okay, so we're going to find the distance between these 2 points and the midpoint between these 2 points. Okay, so let's do the distance first. So I'm just going to go ahead and copy my distance formula. So that would be square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so like I said before, it doesn't matter which one you label as x2 and which one you label as x1. The formula is symmetric, so you can use either one. Okay, so we're just going to go ahead and label this one as x1, y1, and this one is x2, y2. Okay, so let's look at the distance. Okay, so we'll get x2, which is 4, minus x1, which is 5 squared, plus y2, which is 6, minus y1, which is negative 1 squared. Okay, now the only thing that can go wrong here, if you do know the distance formula, is you could make a mistake with signs. So 4 minus 5 is negative 1, squared, okay? And 6 minus -1 is 7. Okay. So we're going to have that this is the square root of 1 plus 49, which of course is 50. Okay, and then we're going to use our skills from the section about square roots to go ahead and simplify this. So we know that this is going to be 5 root 2. Okay, so this is the distance between these 2 points. Okay, so let's look at the midpoint. So remember we had x bar equals x1 plus x2 over 2, and y bar equals y1 plus y2 over 2. Okay, so for us, remember our points were 5, -1, and 4, 6. Okay, so we're going to have 5 plus 4 over 2. Okay, or 9/2. Okay, and for the y coordinate, we're going to have -1 plus 6 over 2, or 5/2. Okay, so the midpoint is an ordered pair, so we're going to give it as an ordered pair. Okay, so it would be the ordered pair 9/2, 5/2. Okay, or you could always write this as 4.5, comma 2.5. All right. So that's how you just apply those two formulas. Okay, so let's see an example of something that's a little bit less clear of just like find the distance or find the midpoint. Okay, so what we're doing here is we want to show that these 3 points are the sides of an equilateral triangle. Okay, so if we just go ahead and sketch this really quick so that we can kind of get an idea of what's going on. We have -2, 1, okay, 0, -1, okay, and root 3 minus 1, which is about 0.7, okay, and then root 3, which is about 1.7. Okay, so if you look at what this triangle looks like, okay, we're looking at a triangle like this, okay, and we want to show that this triangle is equilateral, okay, and we know that this means the sides are the same length. Okay, so it's obvious that these 3 points can form the vertices of a triangle. So what we're being asked to show is that these 3 sides really are the same length. Okay, well, the length of these sides is the distance between the vertices. Right, so the distance between the points is the same. Okay, so let's just name these points. This guy is A, B, and C. Okay, so this would be A, B, and C. Okay, so we want to show that the distance between A and B is the same as the distance between A and C and B and C. Okay, so we're just going to look at the distance, each of these three distances, and then hopefully we can show that they're the same. Okay. All right, so remember our distance formula is square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so for these points, we can pick any of these distances because we're going to do each one of these, right? So let's just do A and B first, and then we'll look at each of these other two distances. Okay. So we're looking at the line segment AB here. Okay. So this is going to be the distance between the 2 points -2, 1 and 0, -1. Okay. So this is going to be x2 is -1 and x1 is -2. Okay. y2 is, oops, I'm sorry. x2 is 0. Let me rewrite this. Okay. So we're using this point as x1, x2, and this is, or I'm sorry, x1, y1, and x2, y2. So x2 is 0, and x1 is -2. Okay. y2 is -1, and y1 is 1. Okay. All right. So 0 minus -2 is 2. Okay. And -1 minus 1 is -2. Okay, so we're going to get square root of 4 plus 4, or root 8, okay, which we know is 2 root 2. Okay, so let's look at the other line segments and see if we get the same length. Okay, so that was the line segment AB. So let's look at AC. Okay. So when we're looking at A and C, we had these points. A was -2, 1, and C was root 3 minus 1, root 3. Okay, so this is going to be x1, y1, and this is x2, y2. Okay, so the length is going to be x2, or root 3 minus 1, okay, minus x1 squared plus y2, okay, minus y1 squared. Okay, so this is going to be square root of root 3 minus 1 plus 2, which would be root 3 plus 1 squared, plus root 3, oops, minus 1 squared. Okay, so we're going to square these out. Oops, minus 1. Okay, so root 3 times root 3 is root 9. Root 3 times -1 is negative, oops, these should both be plus. Root 3 times 1 is root 3. Root 3 times 1 is root 3. Okay, and 1 times 1 is 1. Okay, so that's what we get from the first one. Now here I'm going to get root 3 times root 3, which is root 9. Root 3 times -1, which is negative root 3. -1 times root 3, which is negative root 3. And -1 times -1, which is 1. Okay. All right, now when you look at these terms, right, you can see that this positive root 3 is going to cancel with this negative root 3. This positive root 3 will cancel with this negative root 3. Okay, and I'm going to get root 9 plus 1 plus root 9 plus 1. Now root 9 is 3. Okay, so I have 4 plus 4, or root 8, which is 2 root 2. Okay, so exactly the same as the previous side. So we can see that at least these two side lengths, right, AB and AC, AB and AC are the same side, or the same length. So now we just need to check that this side, or BC, is the same length. Okay. So we'll have the square root of x2, so that's going to be the x coordinate from C, or root 3 minus 1, minus the x coordinate from B, which is 0, okay, plus the y coordinate from C, which is root 3, minus the y coordinate from B, which is negative 1. Okay, so this is going to be root 3 minus 1 squared plus root 3 plus 1 squared. Now, if this looks familiar to you, it absolutely should, because this is exactly what we had in the previous example. Root 3 plus 1 squared, root 3 minus 1 squared. Okay, so we know from calculating this before that this is going to be exactly root 8 or 2 root 2. Okay. Now, what can we conclude from this? We can say that all sides are the same length. Okay. So our triangle ABC is equilateral. Okay, so this is just one application of the midpoint and distance formula, right? We really only use the distance formula here, but we used it to show that the sides of this shape are the same length. Okay. All right. So let's go ahead and start talking about circles. Now, obviously you guys know what a circle is, but let's give the precise mathematical definition of a circle. Okay, so the precise mathematical definition is that a circle is a set of all the points that are equidistant from a fixed point called the center. Okay, so you guys know what a circle looks like. If you fix any point and draw all of the points that are the same distance away from that, you'll be dotting a center point and then drawing a circle around it. Okay, now this distance from the center point has its own name. Okay, and that's called the radius. Okay. All right. Now let's really quickly draw a circle. I'm going to draw something as circular as possible. Here we go. That's pretty good. Okay. So obviously this point is the center. Okay. We would call this distance here the radius. Okay. A line that goes through the center from one side to the other is called the diameter. Okay. Now, a line that does not go through the center is not a diameter. That's something else. It's called a chord. Okay. But the diameter has to pass through the center point. Okay. And the center would cut the diameter exactly in half. So this half is R and this half is also R. Okay. All right, let's look at the equation of a circle. Okay. Okay, so this is the standard form of the equation of a circle, okay, where HK is the center of the circle and R is the radius of the circle. Okay, so let's do an example of using this. Okay, so we're going to state the radius and center of the circle, and then we're going to graph that circle. So the equation we're looking at is x plus 3 squared plus y minus 2 squared equals 16. Okay, so we can see that this is in standard form, which allows us to read off the center and the radius. Okay, so the center is going to be -3, 2, okay, coming from here and here. And the radius is going to be the square root of this number, or 4. Okay. The reason we know this is because r squared equals 16, so r must be 4. Okay. All right. Now to graph, okay, let me grab some graph paper and we'll go over the best way to graph a circle. Okay, so to graph the circle, we're really going to graph the center. Okay, so let me copy down the center and the radius. Okay, so we have the center and the radius. So what we're going to do is draw in our axes. Okay, then we're going to dot the center point, so -3, 2. Okay, and then we're going to draw the circle by drawing 4 units in each cardinal direction. So we're going to go straight up and go 1, 2, 3, 4. So this is going to be a point on the edge of the circle. We're going to go to the right, 1, 2, 3, 4. This is going to be a point on the edge of the circle. Down, 1, 2, 3, 4. That's a point on the edge of the circle. And to the left, 4. Okay, so now you have 4 points on the edge of the circle. Here's the center of the circle, and you're just going to try to draw it in as good of a circle shape as possible. Okay. All right, there you go. So that's really all there is to graphing the circle. All right. Let's see an example that's the opposite of this, where we start with the center and the radius and we write the equation. Okay, so we're going to take the base form, which looks like this. Okay, and we're going to fill in the information. So here's our center HK. So we're going to have x minus 1 squared plus y minus -2 squared equals r squared. Okay. Now, the only thing I'm going to do to simplify this is to change this minus -2 into a plus 2. Okay, and my 3 squared into a 9. Okay, and there's the equation of this circle with this center and radius 3. Okay, all right. Now, let's do another example of writing the equation, but with slightly different information. Okay. So now we have an example where we just have 2 endpoints of the diameter. So remember, a diameter is a line that goes right through the center of the circle. So these 2 points are where that line through the center of the circle intersects with the circle itself. Okay. So if we look at what this is looking like, okay, we have 1, 5. Okay, and then 3, -1. Okay, now these are a diameter, okay, meaning that the circle is going to look something like this. Okay, now the center of the circle is going to be halfway between these 2 points. Okay, so what that tells us is that the center is going to be the midpoint. Okay, so let's look for the center of the circle by finding the midpoint of these 2 points. Okay, so our x-coordinate of the center is going to be x1 or 1 plus x2 or 3 over 2. Okay, so this is 4 over 2 or 2. Okay, and the y-coordinate of the center is going to be 5 plus -1 over 2, still 4 over 2 or 2. Okay, so our center is going to be 2, 2. Okay. You can even see that that's similar to what we have drawn on the graph, right? This does look like the point 2, 2. Okay, and you can see that it's exactly halfway between these two endpoints here. Okay, now the only other information that we need to write the equation of the circle, right, as we saw in the previous example, is the radius. Okay, so that would be this distance here or this distance here. Okay, so let's look at the distance between 1, 5 and 2, 2. Okay, so we're having 1, 5 and 2, 2. Okay, so the radius is going to be the distance between these two, right? Because that's this distance here. Okay. So we have x2 minus x1 squared plus y2 minus y1 squared. Okay, so this is 1 squared plus negative 3 squared. Okay, or square root of 1 plus 9, root 10. Okay. So to summarize the information that we have, we know that the center is 2, 2, and our radius is root 10. Okay, so we're going to fill that into this information. Okay, so h is 2, k is also 2. Okay, and then we have root 10 squared. And the only thing we need to do to simplify this is say that root 10 squared is just 10. All right. So that's all for that example. Okay. In the next video, we're going to go over changing between this form, the standard form, and the other form for equations of circles. So I will see you guys soon.